What I'm going to do is just give you a quick introduction to what we call OKE, which is our Oracle Kubernetes Engine, which is a managed Kubernetes service on OCI, and give you a sort of a look into spinning up a cluster and just deploying some apps and just having a look at proving that it works, basically. So I've started with this slide because probably most of you didn't know that Oracle had a cloud native strategy, or even if Oracle had much of a cloud, to be honest. But the team that I work in, I'm part of the product management team for our container native offerings, specifically looking around our Kubernetes Engine and our registry and some other new ones that are coming on. And what we're trying to do is to make it easy for guys like yourselves with modern workloads, with cloud native workloads, to be able to get onto our platform, but also make it easy for traditional Oracle customers to move on to container native offerings. So we've got a whole bunch of customers and partners that currently deploy, so if it's ISVs, deploy their applications on-premise using WebLogic and running Java apps. So one of the things that we've done is we've written a WebLogic Kubernetes operator that makes it really easy to deploy WebLogic applications onto Kubernetes, and Kubernetes understands how to scale WebLogic clusters, etc. So we've got a bunch of ISV partners that have got that, and they're trying to move to become cloud native and stay relevant to their customers as they move forward. And this is starting to be very popular in that environment. So we're trying to make sure that we can take existing and new workloads. So as we sort of covered before, we're trying to be sustainable. So it's trying to make managed service using open source, but curated and managed in that way to avoid locking. We're taking full advantage of the performance and the security of the underlying infrastructure. And we're playing in the right game in open source by using, when we create a service like Kubernetes, we're using pure upstream Kubernetes. The only things that we do is we add to that. So we add an OCI cloud provider, we add an OCI persistent volume claim operator as well. But they're all given to open source, or open source part of the Kubernetes environment. So we're members of CNCF. We go to KubeCon, we sponsor KubeCon, and we've got an active participation in open source projects. So what we did at KubeCon in December is basically announce a couple of things. So one was this cloud native framework, which allows us to take advantage of Oracle Linux and its Kubernetes support to be able to say, right, we've now got a sensible framework for being able to deploy to cloud and to on-premise environments. So that was the cloud native framework. We announced 6 new services that are coming on Oracle Cloud Infrastructure. And we also announced a managed function service, so based on the FN project as well. And these are all things that framing our what we're calling a sort of container platform strategy that will hopefully make it easier for people to actually consume a secure, reliable environment around Kubernetes and functions, etc. So what we've got is we have CI/CD platforms. So again, we're totally agnostic. Most people bring their own, but as we start to get to enterprise customers and they want to move in this, and if they're moving with us, then we have an offering in container pipelines here that people can use, but you use the tool of choice. So we have an OCI registry, which is a full Docker registry that can be public or private, and it's built on OCI, so it's close to the environment. And then we have our OKE environment, our Kubernetes environment, that we can deploy pods into that environment. Then we've announced managed Istio service. So you guys looking at the at your microservices framework, then this is going to be a fully managed and supported, easy, just create the cluster and install Istio in there. Then we're going to build an opinionated but flexible, what we call a software delivery supply chain management, so that when you create a commit and you put a new Docker image into the registry, we'll auto scan that, and as it goes through the deployment stages, we'll monitor, make sure it's secure and scanned, and we'll log all the actions that people do to it to give you a full kind of retrospective view of what's been going on. And then we've creating a marketplace to allow Oracle and customers and partners to be able to give an easy way of deploying solutions and access to solutions. Then we've announced a telemetry and bot monitoring capability based upon the sorts of things that you'd expect, and you've already mentioned Elasticsearch, Prometheus, and all those things. So fully, again, managed open source software that just bring your containers, and we'll manage it in an open source, open environment. And then we've got this concept of open service broker. So we're building an open service broker managed service, so that the open service broker API will give easy access from containers running in OKE to things like autonomous transaction processing database, and these other things that we've announced, the event streaming, etc. So the streaming is a managed Kafka environment, etc. So there's a whole bunch of cloud native services that we're about to release. That open service broker will just be able to plug in through the USB API and give secure managed access to other services. And then on top of that environment, we've got a managed function service that's in limited availability at the moment. It's going GA in the next couple of weeks, I believe. So this is built on the FM project, and it's kind of different than other serverless function offerings in that it's actually built on OKE, so it's using containers as the deployment and management. So this is totally open. So you can build a function and you can deploy it on OKE, or you can deploy it anywhere that you can run FM project. So again, maintaining that kind of open environment. We're also releasing an API gateway, dedicated API. We've already got API gateways. We bought, Apiary a while back. So we have that, but we're building an OCI native version of that. And then we have our OKE and registry service. So we have our OCI registry. You use any tooling that you want and deploy it standard Kubernetes. So what I'm going to do is then flip over and start to look at creating clusters and that. But I just wanted to take you through what goes on, how we build that cluster up and where we run things. So at the highest level, we have an account level, which is called an OCI region, which is what we talked about. Then we have these three availability domains. We have a managed control plane for OKE, and we have that in region, and it spans all the availability domains. And customer has a tenancy, which is the high-level account. And that tenancy has high-level things about security, auditing, object storage. And underneath that, we have a logical grouping of artifacts called, which goes into something called a compartment. And a compartment is a logical grouping of resources that you control a very fine-grained control to. So this is what you start with. So clusters. So I'm going to create a cluster, and it's created it in that compartment. It's going to be called it cluster 1. I'm going to use a custom create.
What is the newest version of Kubernetes?
That is the newest one that we've got at the moment. What we're finding, and we're kind of trying to figure out what the best approach is, but currently we're running two minor releases behind, just because we're managing this, we're taking that, so we're trying to find the best, and we do 2. So at the moment we do 11. We've got 11.5 in 10.11. We've got customers asking to say we want to run 13, which is just out, and it's kind of a balancing act to say, well, okay, well, we've got to manage the migration of an update of that, and is 13 too soon for us to be able to have service levels that we're managing on that? So we're kind of still looking at that, but that's the current ones that we have at the moment. So then we've got compartment. I'm going to give it a virtual network in which to run, and then if I'm going to create services and expose services, I'm going to specify some networking that I'm going to be able to put load balancers in. And then I'm going to, that's okay. We're going to, I shall, I don't know what happened there. I managed to cluster 1. So I'll just use a quick create, which will go off and create a whole bunch of stuff, and then we can install the dashboard and tiller enabled. So this is kind of where we're going to say, well, add Istio, add whatever things at creation time, and we can just go over and do a create. And of course, this is going through the console, but you've got CLI, you've got Terraform, you've got SDKs, you've got any number of ways of actually deploying that. So that goes off and has created a cluster. So if I go back, hopefully so we were there, and we had a compartment, we called it OKE. We created a VCN in that. Then we created some subnets for our worker nodes, and we created some subnets for our load balancers. And so this is all HA. And what went on in the background was that we then, as part of that cluster create, is that we created a cluster controller, and we created a master and etcd in each availability domain across that region with object storage. So we've created a managed set of masters that Oracle keeps maintained, managed, and highly available. So at that point, it's cost you to do that absolutely nothing. There's no cost in that. And then when you create a node pool, you create compute instances for your worker nodes. You can spread those across the 3 availability domains if you want. You don't have to. You've got control of how you do that. So when you spin up a worker node, that's when you start paying for compute, for the core usage for those compute instances. And then if you create a service of type equal load balancer, if you create persistent volume claims, it will create block volume storage, and then you'll pay for the gigabyte hour, whatever the cost for that block storage while it's alive. Then if you create a service of type of load balancer, it will create an OCI load balancer in those load balancer subnets, and that has a cost. It's not much, but it's depending on the speed. So you can have 100, 400, or 800 meg load balancer throughputs. Each has a different cost, and in essence, those are the things that cost to run a cluster. So I've got a cluster in Frankfurt. So if I look inside that, this is not a huge one. So it showed it's created. It's got a node pool, and it's got a node pool of 1. And I'm using a shape of 4 core. So this is 8 vCPUs of a worker node. That's the instance. That's the instance name that we can go get detail. So if I go and look and see compute instances in that compartment, that's created the compute instance that worker node is running in that compartment. So that's the resource that gets charged for. And if we look at networking, you can see it just creates standard OCI load balancer and also persistent volume claims. So that's what it creates in running in that environment. So what we can also do is that we install, as you say, we click the install for Kubernetes dashboard. So we've got that, and then we've got the standard kube dashboard there with the deployments. So there isn't a lot going on in there but what I have got is I've got a set of I've got an ingress controller set up and a default backend, so that when in your diagram, your architecture diagram, when you had load balancer ingress coming back, so we've created an OCI load balancer, and then I've created behind that an Nginx ingress controller. I haven't deployed anything, but I've got just the default backend set there. So that's part that that you can build up a standard kind of topology there. So one of the things that we've been doing is that we're working with Bitnami a bit, and one of the things that they've got is this concept of kube apps. So it's a curated set of Helm charts for deploying solutions from a marketplace, but it's also an easy way of deploying these charts in a very simplistic way. And what it does is kube apps is just something that you install in your cluster. It just runs in its own namespace, and then you get this dashboard. And we've got a catalog of available solutions. A lot of the stuff that's already been talked about, but just as a simple to make sure I get the right one. So Drupal's a standard kind of solution with a database and etc. for writing, publishing content. So what we can do is we can deploy that using Helm, and you can see the standard Helm chart here with services, with the database definitions and etc. So you can modify that if you want, but this is just standard. This is just standard stuff. So when we show, for example, so it says here on the chart that if undefined, it doesn't mention OCI, but it will just default to and use the OCI provisioner, and type of load balancer, it will create the load balancer. So just deploy that, he says. So that's now running the install for that. If we looked at overview, we can see that deployment is now underway. It's creating pods and deployments. It's waiting for the volumes to be created. It takes normally about 2 minutes to do this. So what I'll do is go back and show so it's probably created the networking. Yes, so there was 2 there, so it's created a new one there, creation date of Tuesday the 19th. So that's going away and creating those resources. And if we come back in, reload at some points, that will go. So it hasn't finished deploying, but it's giving an HTTP, an external of the load balancer. So it's not quite available yet, but as I say, that'll take another couple of minutes. It normally takes about 2 minutes in all to complete. The other thing is that so OCI has a CLI, and we can do OCI CE for our container engine, and we've got full control over the CLI to go in and create clusters, do whatever you need to do through the CLI, as well as the SDKs and Terraform, etc. So he says, hoping that this is going to have, still not quite. That was kind of it. So that's saying that's available now. We'll see if it is. Yeah. So that's the Drupal logging, just to prove that it's actually deployed it and worked. So that's kind of what I was trying to present, was to give you an introduction into the fact that Oracle is kind of not only is in the cloud, but we're really sort of looking at being cloud native. We're behind containers, we're behind open source. We've got the functions, managed function service coming. We've got the managed Kubernetes service. We've got a whole bunch of startups that are on our startup program that are using this, and quite a few of them have moved over from AWS, and the feedback from there and Google, in fact, is that this offering is really performant and rock solid and reliable. And we've got one startup based out of Bristol in London that moved there. They've got an image recognition system that they use for shopping, for fashion shopping, so that you can show it a picture of a handbag and it will go off and do whatever women want to do with their searching for their handbag. But they've got an AI ML algorithms that they do that, and they've moved from Cube on Google over to OCI, and for this they've reduced their deployment times, they've reduced their costs, so much so is for the same cost as running a Kubernetes on Google, they can run their Kubernetes environment and run their GPU environment for exactly the same cost. That's just an example, but all these guys are using this. And yeah, as Ab said, you can get out and try it, free trial, and you can spin up one cluster per region. And if you think it's $300 and it's only a few cents per CPU that you're paying for, then you'll be able to run quite a lot of cluster time for nothing.
Okay,
cool.
Great. We got time for 2 more questions before we all go for beer. 2 more questions.
No questions. Beer.
No questions? No questions? 2 questions?
Do you have some Docker repository of RAID on the Oracle Cloud?
Yes, that's the OCIR, the repository. It's a standard Docker 2.
Sure, it's like.
You were saying.
Oh, was I? So it's just like Docker Hub, but it's hosted on OCI. So it's secure. So you can have it in the same private VCN, or you can have it public.
And one more question, go ahead.
Do you support attaching GPU from Kubernetes?
I've got to say yes and no. So this is full disclosure. At the moment, the engineering work for it is done because there wasn't much to do. It's just sitting in the backlog for deployment because right now the focus from engineering is on getting some updates done in the platform to allow a whole bunch more services. But what we do have is a Terraform script provided that will allow you that will straightforwardly spin you up a self-managed cluster that supports, you can run GPU. But what does work is that we've got an HPC shape of compute, which is higher clock speed, slightly lower number of cores on the CPU, but it's got an RDMA clustered network backplane. So for workloads that are like networking, use RDMA, etc., then it's really quick. But it's just where we are in our release pattern. It really bugs me that the work's done but it hasn't been. It's because we got quite a few customers saying, we've got them all lined up for the limited availability, but it's not going to be before the end of May, unfortunately.